So now we're going to do problem number 41 from chapter 5. This is an elevator cab that weighs 27.8 kilonewtons, moves upward. What's the tension in the cable if the cab speed is increasing at a rate of 1.2 meters per second squared or decreasing at a rate of 1.22 meters per second squared? So first let's start off by drawing a picture of this. So here is my elevator. Looks a lot like a box. And so what forces do we have here? We have the weight, which we know the weight is 27.8 kilonewtons, which in my opinion is easier to convert to newtons so that you make sure you don't mess anything up. So I have 27,800 newtons. And the other force that we have here is tension. And regardless of whether we're moving up or moving down or increasing or decreasing our acceleration, tension is always pulling up because that's the thing that's making you not die when you're in an elevator, is the cable right above you. So anyway, here we are, and we know that we are moving upward. Moving upward tells us about our velocity. So I will draw my velocity going up right there. And the reason we care about this is because when they tell us that the speed is increasing or the speed is decreasing, that tells us what direction our acceleration goes. So I wrote in a little cheat sheet for you guys. If we have increasing speed, that means that our velocity and acceleration are in the same direction. If I have decreasing speed, then velocity and acceleration are in opposite directions. And this is always true. For this particular situation, maybe it was intuitive to you anyway which direction the acceleration was going, but it's hopefully helpful with this sort of key here. And so for part A, if my speed is increasing and my velocity is going up, then that must mean that my acceleration is also going up. And so what I like to do is I like to draw my entire free body diagram with a little indication of my acceleration right next to it. And so this is not a force. This is obviously an acceleration because it says acceleration. But I draw it because that tells me when I am summing my forces, so I have sum of the forces equals mass times acceleration. If you choose your positive direction to be in the same direction as your acceleration, then that's going to make your problem easier because then you can use a positive number right here. So that's what I'll do here. So for part A, up is going to be my positive direction. And this is what you can always do for elevator problems, is just figure out what way your acceleration is going and then sum your forces. So I will have tension, because that's up, minus my weight, that's the sum of my forces. This equals 2 mass times acceleration. And so since I want to solve for my tension, I'll put tension on one side, move the weight over, so I'll have weight plus mass times acceleration. So tension equals my weight, again, is 27,800 plus, oh snap, we need the weight, or sorry, the mass. And so I'm going to go over here. I remember that my weight equals mass times gravity. So I have 27,800 equals my mass times 9.8, which tells us that our mass is 2836.7 kilograms. Cool. So I'm going to take this, put it back over here for my mass. So I have 2836.7 times our acceleration. And we are told that your acceleration is 1.22 meters per second squared. So with this information, we find out for part A that our tension is 31,260 newtons. We were done with that part. Bum, bum. So now just part B. Now my acceleration is decreasing. Mathematically, I could just put a negative in here and I would get the correct answer. But I want to show you how I would do this a little bit more intuitively, just so that you can make sure to not make any mistakes on your future problems. So again, I would draw my entire free body diagram, which is pretty simple in this case. But since my speed is decreasing, and we have a little key here, velocity is up, therefore acceleration is down. So I'm going to draw my down acceleration right here. Again, not a force vector, just an indication of the direction. So what that means for me right now is when I'm summing my forces, I'm going to have the down direction be my positive direction. So the equation here is going to look a little bit different than that one. I'm going to have weight, which is positive, minus tension, which is negative, still equals mass times acceleration. This allows me to use a positive number right here in my calculations. And so I'll move my tension over to this side, I'll move my mass times acceleration over to this side. So I have weight minus mass times acceleration equals my tension. And now I can plug everything in and we're going to solve. So here, I'll bring it over here so we can see it a little better. So our weight, again, 27,800 minus, our mass is still the same, 2836.7 times that acceleration, 1.22, equals our tension. And if I figure this out on my calculator, I'll find out that my tension is 24,340 newtons. And so we're done. Hooray for us. But I just want to make a quick note that I think that sometimes when people are doing elevator problems, they feel as though they should be able to skip directly to this equation or to this equation. But I never do that. I always start with the sum of the forces equals mass times acceleration, and consider the direction of your acceleration so that you don't make a mistake. And that is it. Hope that helped. Bye-bye.